Hi students, welcome back. Today I want to talk about chapter 15.2c. Last week we started with describing solution composition. We started with molarity, and today we're going to practice with molarity as well, and then we move on to dilution. So molarity, what was it? It was the share of moles per volume of solution. And we're going to express that in moles per liter, and that is the moles of solute divided with the liters of my solution. And we also call that concentration. And we indicate the concentration or molarity with a capital M. So 1.0 M means 1.0 moles per liter. I showed you this overview, how to come from moles to molarity. When I know the moles, I divide with my volume of my solution, and then I have my moles per liter. If I know my molarity, so my concentration, and I know my volume, then I can multiply these two and I get the number of moles. Also, remember how to come from mole to grams. So I'm from moles, I multiply with the molar mass, I get grams, and from grams back to moles, I divide with the molar mass. Let's one example from the textbook about molarity. So here I have 15.7. It's about formaldehyde. And the question is how many grams of formaldehyde do I need to prepare a 2.5 liters, 12.3 M formalin solution? So how are we going to answer that? Well, let's see that. First of all, the 2.5 liter of 12.3 moles per liter, when I multiply these two, you can find out that we need 30.7 moles of HCHO. You see the structure formula in the upper right corner. So what the question was about grams, so I need to find what's the molar mass. So we can do that, and that's 30.0 grams per mole. So now I have 30.0 grams per mole, and I have 30.7 moles. I multiply these two, and I get my answer, 923 grams of HCHO. This is about the molarity. Let's continue to dilution. So when we do labs, we often buy very concentrated solution, so it's easy to stock. So those concentrated solution, they contain a large amount of solute, and that results in a very high molarity. But for safety reasons, we use less concentrated solution during our lab. So they're diluted. So how do we do that? We have the concentrated and we offer the diluted version. So how we do that? We just add water, only water. And really important to remember and to understand this is that the number of moles of my solute after dilution is the same as the number of moles of the solute before the dilution. So the moles of solute is constant, and we'll see that later. So let's have a couple examples. So hydrochloric acid, we buy 5 liter bottles, and that has a molarity of 18 M. But for a lab, I want to have in 1 M HCl solution, and I want 2 liters of that. How am I going to do that? I will show you step by step in the next slide. So we're going to make 2 liters of 1 M HCl solution. And remember, molarity is moles over volume of solution. So I want 2 liters of 1 M solution. So what I need is 2 liters times 1 mole per liter is 2 moles of HCl. That's what I need. How do I get these 2 mole HCl? I get these out of my concentrated HCl solution, and it was 18 moles per liter. So 2 moles is 18 moles per liter times an unknown volume. That's what I have to take from the very concentrated solution. So now I can calculate what is that volume. 2 divided by 18, 2 moles divided by 18 moles per liter is 0.111 liter of my concentrated HCl solution. That's what I need, because then I have 2 moles, because 0.111 times 18 is 2 again. So now I have my 2 moles. So I take 0.111 liter of my concentrated HCl solution, but overall I have 2 liters. So I'm going to add up to water, with water, until 2 liters. So 2 liters minus the 0.111 of my concentrated HCl, and that is about 1.889 liters of H2O. That is what I have to add to my concentrated HCl to get a 2 liter 1M HCl solution. And let's check. Before the dilution, I had the volume and my concentration, I had 0.111 liter times 18 moles per liter is 2 moles. And after my dilution, I had a concentration 1m and a volume of 2 liters. So 2 times 1 is also 2. So you see the number of moles of my solute is constant. Or in formula, my molarity in situation 1 times my volume in situation 1 is the same as my molarity in situation 2 times my volume in situation 2. So the number of moles of solute is constant. Okay, one more. A volume of 16 m sulfuric acid, really concentrated and really nasty when you have it on your hands, must be used to prepare 1.5 liters 0.1 m H2SO4 sulfuric acid solution. What's the volume of my concentrated sulfuric acid do we need, and how much water? Let's answer that the same way as we did for the previous slide. So we want to finish with 1.5 liters 0.1 m solution. That means I need 0.15 moles of H2SO4 because 1.5 liter times 0.1 mole per liter is 0.15 moles. How do I get this? We get this out of my 16m, my concentrated H2SO4 solution. So now again, I can find out what is my volume of my 16m solution I need. So an unknown volume times 16 moles per liter is 0.15 moles. So 0.15 divided by 16 moles per liter gives me 0.0094 liters. It's only 9.4 milliliters, since 1 liter is 1,000 milliliters. So I only need a little bit of my concentrated H2SO4. Overall, I have 1.5 liter, that's my total volume. So I know how much water I have to add. 1.5 liters is 1,500 milliliters. And I know I need 9.4 milliliters of concentrated sulfuric acid. So what's remaining is 1,493.6 milliliter water I have to add. And then I have my 1.5 liter 0.1 m H2SO4 solution. Finally, I want to talk about an exercise from the textbooks, 15.8. What volume of 12 m, the concentrated HCl, must be taken to prepare 0.75 liters of 0.25 moles per liter HCl? Again, we end with 0.5 liters, 0.25 m HCl solution. So we can calculate how much mole HCl we need. And that is 0.75 liters times 0.25 gives me 0.81875 moles of HCl. That number of moles of HCl I get out of my concentrated 12m HCl solution. So I have to find what volume do I need from a 12m HCl. So same formula, an unknown volume times 12 moles per liter is 0.1875 moles. That means for unknown volume is 0.1875 divided by 12, and that's about 0.01563 liters, or that's about 15.63 milliliters, and let's round it to 16 milliliters. That's what I need. I only need 16 milliliters and fill it up with water to have at the end 0.75 liters of 0.25 m HCl. Okay, this example, I want you to study. What I want you to do next, guys, is to study this presentation that's on Schoology. Study the chapters 15.2b plus c from the textbook. And then I have an online worksheet on dilution that's ready on Schoology for you. So for next class, we continue with the molarity. There will be a simulation to play around with molarity to calculate and make solutions. And then we're going to do the final part of this chapter is stoichiometry of solutions, reactions. So then we have to do balancing chemical reaction and to calculate how much is needed. Okay, that's it for today. Good luck, everyone, and see you again. Bye-bye.